Game One, or at least one last night. We're still working on the rest of that series. We've been a little bit baseball obsessed over the last few days. So that's exciting for us. It's been an interesting week. To be honest, I haven't been particularly motivated, even though I've cranked out like three different new projects. One of the I think might be like the fall doldrums or something for me. I don't know what's going on. But I do have some new things to show you guys today as well. So I've been working on a couple new projects using the concepts of stream-based introspection, and which is a little bit hard to sort of get your head around. So I needed to create an application of it. So I'll show you some of the stuff that I'm building there and what we're doing there. I see Dragon here on my screen. How's it going? You had your first meetup there on Tuesday, I think.
Yeah, on
How'd that go?
Tuesday in Novi Sad, there was, I think, something 30, 35 people, in the space in Started AI Hub. Uh, Couple of people online. It was recorded with Zoom and it's shared on the YouTube. I shared that on the LinkedIn. If somebody is following, can check the recording. I didn't pray enough to demo gods, so I had a problem with demoing one of my platforms. But okay, learning points for the next time.
Yeah, that's a thing. Every time, and the I think the better you handle broken things, and actually when things break, sometimes the most interesting presentations are not the thing you built, but how you fix the thing you want it to show. And as anyone that's tuned into the Vibecast, like that's half of the things we do is like, oh, I built this, but actually now it's broken, and I broke it 5 minutes before the call started, kind of activity. So yeah, what broke? Docker containers? Is that what
Yeah,
you say?
Docker container stalled after, computer went to sleep while I was going to the meetup. So I didn't check before the start of the session. And when I went to the app, oh, okay, I know of the problem, but yeah, I tried to fix it. But okay, next time, I will know. I will just restart the Docker and then everything will work.
Oh, okay. Well, yeah, happens for sure. It's always a Docker cache issue, or if you
Mhm.
if you need something to blame, just blame it on DNS. That's my go-to. It's the black art of
Yeah,
DNS.
definitely. Ports get stuck, so some process, stays in the work in the background. So, yeah, and then the, next service is started and it overlaps. So classical.
I I knew you heard about the outage on at AWS last week. They literally
Yeah.
blamed DNS, and whenever you hear a DNS, it was the issue. You know it wasn't actually the issue. It's probably something they don't want to actually disclose, and so they're like, okay, it was a DNS issue. So that's like a way to describe the something that isn't the actual problem. All right. Oh, wait. I need an update from Nick on the baseball because I know enough to be dangerous, but he's the expert here. Nick, uh, how's it going on our favorite baseball team?
It's going great. We had another legendary performance from the rookie Trey Savage. We're talking like record breaking for rookie pitchers in World Series history. But there's this Japanese pitcher. His name is Yamamoto, and he's had two complete games in the playoffs back to back, which is basically unheard of. So we got to deal with him tomorrow. But I'm confident that going back to Toronto, we've got two cracks at it. We'll get it done in one of those two games. So huge for the country here, all Blue Jays fans, and lots of converts coming through. So it's been great.
Someone was telling me yesterday that the Osani, or however you pronounce his name, the big star from the Dodgers, gets paid so much that the amount of money he made the first time he showed up at bat was how much that Savage guy made for the entire year. So basically, he made as much money swinging the bat once as this other guy does for a year.
Yeah, and he's at around $57,000 because he was at the lowest level of A ball, but he has this World Series winning bonus, which is super highly unlikely, of course, but it's part of their contracts, and he's lined up to maybe get 300,000 or so bonus check coming his way.
Yep.
Assuming the boys can get it done.
Yeah, well, that's exciting. So, all right, well, we'll see how it goes. And if you are in LA, we'll good luck. May the best team win, I guess. Um, all right. So, oh, I see Jed. Jed, how's it going?
It's
Wait, any
going.
build anything interesting this week?
Well, now that we're making AI more and more accessible where I work, we've recently put together something that allows more universal text extraction from a growing number of files. So upload a file, get its text out, and then you can start asking questions of that file. And it's not limited to things like PDFs or Markdown or documents. It's now extending to the likes of PowerPoints or Excel files and the understanding that comes with it.
So you're doing like some kind of like embeddings for these files
Not even
and asking.
embeddings, it's strictly extracting the text just so the text can be added to the context against which questions are asked.
And you so you're dumping the entire contents of a file and then saying, "Tell me about the file."
But yeah, the text is being, how do I put this, is being extracted and made available.
Okay. Well,
So
opposed to
it
sort of
sounds
context.
it sounds simple in practice, but it's meant to be. A lot of work went into making it easy for the users to consume.
Okay. Well, that's the and a lot of us spend quite a bit of time figuring out how to do contextual embeddings, where you have just the parts of the file you need. And now the problem with the contextual embeddings is sometimes it loses the context itself of where and how that's related to other parts of the file, and or even where and how it relates to other parts of the file immediately, before and after the part that you're looking at. So you're basically taking all of it and doing a kind of context stuffing, saying here's everything rather than here's just one thing.
Well, when you have 400,000 tokens of context, that's a lot of file. So it's a future problem.
Yeah, definitely a future problem. That also brings up when are we going to get the million context for Claude code? So they've got a million context support in LLMs, yet for some reason we're still stuck with 200K. Come
Sonnet
on,
1
and
million is available. You have to explicitly connect
it's
to it.
only it's only available if you use the API, I think, unless I'm missing something.
Upgrade to
You
at
are
least
correct.
version 2027.
Oh, so it is available in for non API because I
It's
haven't seen
available for
that.
Claude Max.
All right, well let's start there. I'm curious how do we get that activated? So let's see if I can dig around here and figure out how to get that going. Because having a
Slash
million,
models. Mm.
all right, let's do that.
Slash models, and let me just confirm the
All
version
right,
I'm running.
let's take a look here. So I've been stuck in 200K land, so I'm gonna see if I can get the. You're saying that one of these says models. I only see three.
Check your version. You
All
may
right,
need to reinstall Claude Code, or did they take it back again? Hold on.
that's a good question. 2.029 is what I'm running.
Nope, looks like I hallucinated. They took it away again.
Because if I could I have figured out how to get a million. I just haven't figured out how to get a million using my Max. I can if I switch to the API version, that you've got different options. And I was able to get a million using the Agentic Flow system, where you can choose different models and proxy it. But I haven't been able to do it through the lower cost Max option. Also, check this out. My weekly reset is 3:59 UTC, which just so happens to be 12 p.m. Eastern on Thursdays. So I'm like always I like is it gonna work? Am I gonna be able to do any kind of demos or I'm gonna have to switch my API keys? Well, luckily it resets. Let's just take a look here and make sure I'm reset here. I'll be my old DSP here. But I do have some things to show this week. Oh, yeah, went away. Looks like we're good. I'm now able to do my demos. It's of all the times to refresh, this is definitely the best possible reset time. All right. Actually, before I jump in, anyone have any comments, things they want to discuss? I see I got Brad on here. How's it going, Brad? How's Harvard land going for you? Well, putting Brad on the spot here. Oh, John, good to see you.
Hi, can you hear me?
Yeah. What's happening?
Okay, so I think it's called GTech. I watched a YouTube video of it with Jensen Huang giving his presentation, and he said something, I think, that NVIDIA was going to give open source people free access through Hugging Face to all the various models, like the Qwen and the DeepSeek on Hugging Face. And I've tried to find out something about that and haven't been able to find it. I wondered if anybody else knew anything about that, because that would conceivably be a great boon to this group and groups like it.
Yeah. We should definitely reach out to our friends at NVIDIA and see what that's about. That would work great for some of the proxy stuff we're doing. And a lot of the models on Hugging Face are obviously quite capable at this point, so that would be a nice way to save a few bucks. Yeah, so if anyone from NVIDIA or knows anyone at NVIDIA, let us know. It's something we'll certainly want to explore. All right, I'm going to jump in and do some vibing. Again, like if you have questions, I'm going to do my best to keep an eye on the chat. So feel free to pop in there or just interrupt me. I'm going to show you some of the stuff I'm working on this week. So here we go.
Figured it out, Riv. I'm
Oh,
proxying Claude Code through GitHub Copilot Enterprise to get access to the Sonnet 1 million for what I assume is a fixed monthly fee, or at least I don't see the bill.
you're sorry. Say that again. You're
I'm
proxying through.
proxying Claude Code through the GitHub Copilot connection to Anthropic, and that's how I'm getting the Sonnet 1 million context into Claude Code.
Well, that's an interesting approach.
So
Okay.
there's a GitHub Copilot Pro or Pro Plus subscription. I think it's $40-something a month, against which you can have access. I think it's 1,500 requests to a premium model. And if I remember correctly, the Sonnet 1 million is not classified as a premium model. It's technically unlimited, or at least till you
Well,
find the limits.
okay. Sounds like an update I need to do to my agentic flow system to include the GitHub as a proxy option.
It
Uh,
won't
ne-
work
ne-
in an independent container. It has to go through, in this case, VS Code.
okay.
So
So
the
you
same way
basically,
Root Code used the GitHub Copilot subscription to access GPT, whatever, can now be applied to use GitHub Copilot subscription to access Claude.
got it. Okay. Well, okay. Well, that's good to know. All right. So we're gonna do a little bit of I'm gonna give you a little background here on some things I'm working on. So, couple things I want to show. I haven't actually posted this broadly yet, although it looks like about 700 people have downloaded. So, thank you. It's amazing that so many people download something I haven't even announced. But I'm going to show you there's a couple things I've been working on that's probably interesting for you guys this week. And one of which is this is a project that I done several months ago called Midstream. Now I had to call it Midstreamer because someone else owned Midstream on NPM, so Midstreamer here. Now what this tool does is essentially allows you to do a kind of introspection on the flow of information in real time. So when you think of these models, a lot of what's happening is you're making a request and then it's streaming the response back to you, right? And when you see a streaming response, you see it sort of typing on the screen or displaying as the information comes back to you, and then you're getting a final sort of result. Most systems wait for that final result to happen. You ask a question, you get the answer, and once the answer is complete, you're done. And then the system will say, okay, it's done, and then it'll do whatever it needs to do. You can reply to it or take actions on tools or other things. Now, the problem with that is there's although it seems like it's faster because it's kind of rendering as you make the request, it's not actually any faster. You're just getting it in a way that it appears faster, and it's difficult to make any kind of actual use of that information until it's done. So what I was doing here is I created a system again because I love Rust that allows you to gain sort of introspection into those streams. So what I'm doing is I'm essentially monitoring all the information that's flowing in real time, and then I can do things that allow me to watch for certain types of actions. It could be relating to, let's say, stocks or whatever information requires a stream. Now, this is pretty out there, right? This is like you got to know how the inner workings of these systems are, functioning and what it needs to do. Now, I can do that also to do a kind of real-time learning and of the system itself. So this allows me to separate these sort of different streams based on logic, what it's thinking versus what it needs to do, and then I basically can work on it. But again, it's kind of out there. It's kind of complicated and hard to get your head around. It's not what you really need are some practical sort of applications of it. Like, okay, I've got my use cases, right? Real-time monitoring or anomaly detection, task scheduling, things like that. But taking it a step further, what I really want to do is show you like what you could actually do with that. So in this particular scenario, what I've got is AI defense. And for those who are America, I did two packages. I spelt it AI Defense with a S as well for just for my American friends. So, but this interestingly, this one's not doing quite as well. I only got 342 downloads of that one, but 700 here. So give or take 1,000. But what this is doing is a defense system. So some of you might be familiar with the concepts of tools like LLM Guard. LLM Guard is, let me find that for you guys. LLM Guard basically it's probably the most popular security toolkit for LLM, sort of interactions and introspection. So this is, this I think this is Python based as well, if I'm not mistaken. Yeah, I'm pretty sure it's Python based. Let's take a look quickly what it looks like here. Yeah, it's Python. So right off the bat, it's Python, so it's going to be slow. Um, and so basically what this does is similarly, it allows you to sort of define structured sanitation and guardrails and things like that. But again, it's not particularly well suited for sort of stream-based analysis, which essentially means that it suffers from that kind of response issue that I was just mentioning. And so in this case, what I wanted to do is take the best of the bits that I've created and sort of invent, I don't know what the right word is, a system that's much more capable. So that's what the AI defense system is attempting to do. So now what I'm doing here is, again, it acts as a kind of drop-in proxy. So back to what Jed was mentioning a few minutes ago, this allows you to sort of sit in between the system, like your Claude codes or your Roo codes or whatever you're using, and then have it sort of act as the kind of proxy in the middle. Now, the problem with proxies in the middle, if you're using things like LLM Guard or Light LLM or other tools that sort of facilitate that sort of interchange, is you're inducing latency. It makes it slower. So what I want to do is use all the sort of tricks that I've been building over the last month or two around sort of low latency, sort of high speed systems to really have all the benefits to sort of introspection, but also have the ability to sort of understand where and what's happening in any given moment. So and make it faster. So I don't want to make it. I don't want each request to be slower but more secure. I want it to be, if anything, faster and more secure. So that's what I'm attempting to do with this thing. So I've been able to do, using the Rust components, I'm able to do substantially better than the vast majority of sort of the competitive platforms. And I've added a number of different capabilities that don't exist within them. One of which is this idea of neurosymbolic structures. So for anyone that's sort of been following me for the last little while, you know that I think I haven't found any LLMs that aren't susceptible to neurosymbolic exploitation. Neurosymbolic exploitation sounds crazy because it kind of is. And what that it basically means is, rather than using language to exploit these language models, what you can do for pretty much any language model is you can use symbolism. You can use things like Mandarin or ancient Greek or other forms of ASCII structures to basically to instruct the system without explicitly using language to do the instruction. So by doing that, you can sort of sidestep a lot of these systems that are basically looking for those types of prompt injections that are generally defined by language. Like, So, ignore all previous instructions would be the most basic, right? So in an ignore all previous instructions scenario, someone would literally just type in ignore previous instructions. Then there'd be something like LLM guard that would look for the words ignore previous instructions, and then or some combination of those, and potentially the combination of those in different languages, if they're smart enough to figure out that you could say that in French, and then that might get stopped. But taking a step further, the ignore all previous language can also be described without actually saying any of those words, which creates a problem because these systems struggle when it comes to describing, those types of exploits when not using language against the language model. So in this case, what I'm doing is I'm using a kind of cross modal attack vector. So I can look at not just the explicit, ignore all previous instructions, but I can also look at it semantically and have the system learn based on what it's seen and infer what others might essentially be using to exploit the system. Now, this is where it gets kind of mind-boggling a little bit. Taking it a step further, because and this is a slow week, by the way, just FYI. So just to recap, I've got a streaming system that essentially allows me to do really fast stream analysis. I've got a system that allows me to understand what's potentially being exploited, and I've got another system that I devised called Lean Agentic that allows me to instantaneously, well, maybe not instantaneously, but at some ridiculously fast method, actually do proofs. So what this system does is allows me to do novel mathematical proofs using the Lean 4 system that basically creates various types of novel mathematical equations and other structures that it can use to sort of adapt and understand, based on math that's never been done before. Now, let me show you what that looks like. So again, this is a lot of theoretical stuff. So I'm just going to show you Lean. Yeah, here it is, Lean 4. I think this is so what I did in this scenario is I took the Lean 4 project, which is, I think it's a C library, and I converted that to, of course, a Rust-based implementation, natively built. Oh, where's their homepage? I probably need I should probably go with a simpler design like they do on their GitHub. But anyway, so basically what this is doing is mathematical proofs. So I can do thousands, potentially hundreds of thousands. I haven't done more than that of novel mathematical formulations in real time, and then I can either prove them that they work or they don't. So literally, it's creating all these kind of novel approaches to mathematics that'll happen instantaneously that can be used to sort of both adapt and understand what and how the system can be exploited. Now, I'm doing that in again a really fast mechanism, and then I'm cryptographically verifying that using again my new favorite ED2551 signature that basically creates a cryptographic verification to when and how this was either mostly verified, like potentially not verified as well, and then applying that as part of the stream. So in essence, I'm creating a real-time mathematical novel structures that can potentially exploit the AI. So I'm both exploiting my own AI in real time and then using the ability for me to exploit the AI, then to stop others from exploiting my AI, which is a double-edged sword that I could very easily use that for all kinds of terrible things, which I'm not going to do. And if you do use my platform, don't do bad things with it, obviously. But so I'm essentially hacking my own AI in real time, like in sub-millisecond frames, and then saying, okay, I was able to exploit my AI using some random novel component. And before the response is received, I'm patching that particular exploit. And this is all happening sub 100 milliseconds, hundreds or potentially millions of times as the information flows back and forth,
So
which is again pretty out there.
going back
Yeah.
to first principles a minute, do tokenizers cover the entirety of the Unicode character space?
So yes, but the issue that we face here with exactly what's happening is because there's so much happening, it's actually hard to even describe where and how these exploits are actually defined. So I'm essentially creating a infinite exploit loop, checking whether I'm capable of exploiting myself, and then I'm using novel mathematic theorems, proving those theorems, and then creating a cryptographic hash of the proof, and then using that to stop potential exploitation. But that's happening so fast I can't even describe it, right? It's happening in like millisecond sort of increments.
Would this be beneficial putting into your learning database, or is it just so fast you don't have to worry about pattern
And,
recognition?
and that's well, exactly, Brad. I'm it's learning. So what I'm doing is so here we go. I'm struggling to even describe it. It's one of those crazy things that are it's essentially beyond sort of, just I don't know. It's bonkers more than anything. So the key features here, I've got real-time detection, and I've been on my tests, and this is on pretty crappy sort of hosted infrastructure. I could probably get way better than this if I start using GPUs. But just using CPUs, I'm able to get, sub, milliseconds or fractions of a millisecond in this case. I can do prompt injection. I can do, sanitization of personal, identifiable information, normal types of things like SQL injection, neurosymbolic. I've got behavior analysis, so temporal patterns. Temporal patterns would be things that happen within the structure of my nano. So I'm actually protecting against the very things that I'm building, in this case, nano-structured agents, agents that exist long enough in a millisecond or nanosecond, and then I'm protecting against that. Then I'm creating formal verifications using, traditional mathematics and theorem proving. Then I'm creating an adaptive response system that uses meta learning. The meta learning system is actually using the agent DB capabilities that I've devised that allows it to sort of train and use reinforcement learning. So as it learns what types of things I'm able to exploit against essentially myself, it then is able to use a kind of semantic structure that says, well, because in the last 100 milliseconds, we were able to discover three new novel forms of exploitation of the platform, it likely means that there's other, similar exploitations I can use. And when similar things happen, the system doesn't have to go and create a formal proof. It already kind of knows that most likely that is going to be a problem. So it's able to get to that problem more quickly because it infers the potential of the exploit without directly having to see it at that point. So it's essentially predicting that there's a high likelihood of exploitation based on what we've learned in the previous.
Is
But
this tested predominantly on Claude models?
this is tested prominently in Claude models, but what I can do is use my agent flow system to exploit. Maybe exploit's the wrong word. Test and validate on
Well,
other LLMs.
the reason why I ask is the latest GPT models use the O200K base tokenizer, which basically means 200,000 unique tokens are represented in its vocabulary. I don't know the correct term here, versus Claude's, I believe, 66,000 tokens. I am curious to know if an expanded vocabulary of tokens potentially
that?
increases the surface area against which
Okay.
a symbolic-based attack could be performed.
Let's ask. I haven't published well, I published it, but I haven't really done a blog post or anything beyond what I'm showing you guys today. And I'm still trying to figure out exactly how to even describe such craziness. And again, I'm trying to avoid making this the ultimate hacking tool, which I'm a little worried about, to be honest. Yeah.
Does this border on similar concepts that I just posted a chat or a link in the chat to what Stripe did with their foundation payment model, where they basically trained trained a model based on what payments look like?
Yeah, it is similar to that actually, and the idea of similarity is a key part of what I'm doing with Agent DB. I'm inferring, not using inference like you would in a AI model, but I'm inferring based on the causal relationship of different parts of things that I'm seeing. So I'm able to generate a whole lot of different embeddings quickly and then have them interconnected. And then based on that, I can just use natural language or in this case, similar mathematical structures to infer other things from it. So yes, it's almost exactly the same. Now, I'm not actually familiar with this, but I'm gonna take a guess here that these guys are using GPUs and doing a kind of more traditional reinforcement learning. I'm self-learning at scale. Yeah, so everything embeddings for everything. Yeah. So it's interesting to see when I wasn't familiar with this, so this is a really good find. Thank you for sharing that. It's interesting to see when others come up with similar solutions, but they're taking a much more traditional approach. Yeah, let's do this. Let's go here. And Jed, to your question, can you just pop that in the chat? And I'm going to ask the system to sort of explain an answer to your question as well. And I'm just going to have multiple instances of Claude going. I'm just mostly questioning how it works. So in regards to the meta learning system and the agent DB integration, how does our approach relate or is better, different to the Stripe post? Now, I don't know if it lets me view Medium pages. We'll see here in a sec. Give me an overview. Don't create it.
There's lots of links available online. I'll try and get a good one here.
Yeah, so sometimes the Medium sites don't let you do web fetches in Claude. We'll see here in a sec. Yeah, but well, so yeah, but as for Jed's question, say that again, Jed. You're saying that the amount of embedding like characters.
So Claude and OpenAI or Anthropic and OpenAI use different tokenizers. A tokenizer has some number of unique tokens that represent the text.
Mhm.
The Claude model's tokenizer is on the order of 60,000 or I think 65,000 unique tokens, whereas the OpenAI tokenizer for the newer generation of GPT models is about 200,000 tokens. So hypothetically, a larger alphabet of tokens represents a broader surface area against which a symbolic attack could potentially be executed.
Mm-hmm.
Because there are more gaps or more nuances between the different tokens and representations.
I'm not sure how to ask that question, so maybe pop that in as a form of a question, and I'll copy and paste it and see what we can discern from that question. I think what you're saying is more characters, more possibilities of exploitation.
Is there a relationship between the number of unique tokens and the surface area for a symbolic exploitation?
Is there a relationship between the number of tokens,
unique tokens
versus unique tokens?
Right, because number of tokens is just context.
Versus the ability to exploit the LLMs using symbolic attacks. And how does the I originally called it AIM DS, but people don't like when I use acronyms, so I went with AI Defense, but that's the underlying tech that I used here. How's AMD potentially defend against this? Give me an overview. No, I don't know. No MDs. It loves to create MDs. I don't want an MD. All right, let's go back here for a sec. Let's see what's happening here. All right. I know this is crazy technical stuff, so I hope for those that are like not into like wacky, crazy, cutting edge, stuff. My apologies. All right, so let's see if we can get this explained in a way that isn't so out there. All right, based on my analysis of our source code, and I'm in my midstream, by the way, and this is something Jed brought up earlier as well. Maybe I should be creating more GitHub repos. I've been lazy and I create projects and sub-projects inside of sub-projects and it can become difficult to find where the original code and libraries are. Not just for you, but for me as well. When I'm like 2 weeks later, like, where did I do that again? But anyway, our AgentDB meta learning versus Stripe's payment. So this was the question in regards to how does my system relate to some of the technologies that the folks at Stripe were doing around their meta learning. So Stripe's approach, general industry knowledge, payments foundation model, pre-trained transformers on billions of transactions. So what they're doing is brute force, monolithic models, the transaction embeddings. They're converting payments metadata into dense vectors. I'm kind of doing the same thing. Transfer learning, fine-tuning on specific merchant vertical patterns, real-time inference, sub 100 millisecond fraud scoring, similar multitask learning, fraud detection, and chargeback prediction. Their strength, massive data. Of course, I don't have that kind of data, so I have to learn as I go. Unified embedding space for all payment signals, cross-merchant pattern transfer, and continuous learning. Okay. Our approach, the AI defense approach, key differences, real-time streaming versus batch. So that's what I was saying. They're pre-training, I'm doing real time. So my system's learning as it operates. Their system is basically saying, let's figure out everything we ever need to know, and then it's done. I'm saying I don't know what I need to know, but I know I need to know it at some point, and I'm learning as I go. So the Stripe is batch oriented, likely refrains foundation models and accumulate data, hours, days for new patterns. Our advantage is 1 millisecond. So we're 100 times, probably more like 1,000 times, but let's just give them the benefit of the doubt. We're 100 times faster in terms of the feedback loop for pattern detection because I'm doing these super fast little loops that are algorithmically trying to, again, exploit itself based on the information flow to the system. So
when the knowledge is updated, what is being changed? Is it some sort of vector that's represented in n-dimensional space? Is it a JSON object? What is it?
It's a vector and it's a vector being changed. And that's the part I was struggling with actually illustrating here as well. So when you go into where's one of my example files, I'm basically restructuring and resaving that information using a kind of reinforcement, adding points or reducing points as the system is sort of operating. Is it this one that I have it in? And I'm not sure I have it in this one. I'll have to take a look. I got a bunch of databases here, but basically what I'm attempting to do here is basically use a local sort of lightweight data environment. Do I have it here? So this will be my memory entries. This is Claude Flow doing its thing. These are my pattern embeddings. In this case, I'm storing those as binary sort of vectors. I can't show them particularly easily because it's basically just a bunch of random numbers and letters. And then I'm doing sort of a various forms of pattern. In this case, this is my dev environment, so I'm frequently flushing. But the pattern would look like this. Let's see if I can show it a little better.
So how big does a memory or a knowledge or how big does the data artifact get?
I try to keep them small, but usually around 10 to 15 kilobytes. So this would be sort of an example of what it looks like. So it's JSON. In this case, this is looking at like I was doing testing of like throughput. So this is what like a pattern looks like for how I'm testing how to optimize the system for more to work faster. In this case, we can see the confidence in this one was 0.8, so it's a medium. It's a positive. The highest it can go is 0.95, I think. So it's looking at sort of the patterns and how they interconnect to each other, that sort of thing. So I'm using just basically a lightweight vector and storing those in a data structure and then updating them as needed. A little off topic there, but all right, let's jump back here for a moment. I'm gonna close that. I'm rambling. Does this make any sense? Hopefully it does. Maybe it doesn't. So in the most simple terms, according to ChatGPT or Claude in this case, we're better for speed. And I think I already implied that everything I'm doing is trying to be fast, right? I think the key for most of the sort of the future of AI isn't in big and slow. It's in small targeted and fast. So everything you see me do over the last couple months has been really targeting that ability to get these really fast decisions based on math, proving the math, and then in this case potentially exploiting the math. So it's adaptable. I've got 9 different algorithms for continually learning for detection, and the system's capable of choosing what the best algorithm for self-learning is. Where Stripe is using batch, again, big, monolithic. I want to know exactly what's happening. And one of the problems with these types of traditional applied AI or even language models is a lot of what's happening under the covers is kind of magic. You can do an introspection on some of the points, like the requests being made and the export being given after the request. But what's happening inside the actual model itself in those few milliseconds that it takes to come up with a decision is kind of a black box. And it's really difficult to gain sort of view of what's happening. So in my particular scenario, I'm using this idea of judgment and reasoning and pattern extraction and trajectory analysis that I can directly show every step along the way. So there's no black box problem, for this. Multimodal, I can work against anything, text, image, audio, video. I'm particularly well suited for streams of information. So if I'm streaming video, I can gain the insight into all parts of the video, not just what's obvious, but I can look at the audio. I can look at, infrared. I can look at, I can predict what the next likely step is, things like that. I can take it a step further using the agent DB. I've got this idea of reflection that learns from failures, auto restarts workers. It has memory sort of allocation, because I'm using Rust, all these kinds of things. So one guy in just outside of Toronto is able to build and create this on a whim just to show off what my mid-journey thing can do. I'm fairly certain Stripe has a whole team devoted to doing this sort of thing. So at the end of the day, what we have here is a approach that's excellent for batch payment processing. So it's novel in the sense that they can batch and say who's committing fraud, but it's still slow. Well, relatively speaking, and it's probably prone to a lot of hallucinations or what they're calling false positives. Our approach, again, it's a little bit biased, I'm guessing, but regardless, it's fast. False negatives are not like nothing's 100%, but they're a lot less likely because I'm attempting to prove each of the potential exploits in real time, and then essentially trying to exploit myself and seeing if that's possible. So it's going to be really difficult to sort of exploit the system. If you have a chatbot that might accidentally go and say, "Okay, you've convinced me, you can buy that thing for nothing because you entered the right series of prompts." That's going to be much more difficult in my environment. To be honest, their environment, because it's batch based, I could probably point my system at their system and basically say exploit it for good, obviously. And because I'm working so much more quickly than they are, I'm able to basically outthink their system, right? If it's taking them 100 milliseconds to kind of come to a decision, by the time 100 milliseconds has gone by, if I'm doing give or take a million different calculations a millisecond, I've done multiple millions, potentially billions of different combinations to outthink them in orders of magnitude. So from the point of view of can I exploit, Stripe? 100% I could. And that's the problem with this tech that I'm trying to show you, is it could potentially be used for all kinds of great things, but you can probably see that it can be used for all kinds of really bad things as well. So let's see what Claude says there. This is not meant to be a how to hack, by the way. So don't go hacking and say Ruben showed you how to hack. I'm showing you this because this is illustrating how relatively easy it is, if you know how to do it, to exploit pretty much anything involving AI at the moment. Actually, let me stop for a moment. Should I stop here? Jed, am I going down a really bad rabbit hole here, or should I continue? I'm a little worried. I'm like, I just don't want to get in any trouble. But anyway,
I think we're far enough for today's session.
Yeah, it's like anyway. Okay, let's ask more broad questions. How can I use this with the NPX agent? Take flow. All right, flow. And this is how I add new features. And you can see how all my various previous things connect to the next. So I'm just asking open-ended questions. So the first question was like, comparing against what I was doing somewhere else. And I'm gonna let that run for a minute. Let's jump back here for a sec. All right. Let's see. All right. This was Jed's question around the relationship between tokenization and symbolic attack vulnerabilities. So Claude has the CLI 100K base, and OpenAI use a different tokenizer with varying vocabulary size. The key vulnerability isn't the number of unique tokens, but rather the boundary exploitation. Attackers craft inputs that tokenize differently than intended, creating semantic gaps between what humans see and what models process. All right, so what humans see and what models process. Okay. Multiple byte character abuse. Unicode sequences that fragment across token boundaries can hide injections. Multiple. Okay, I might have to get them to explain this to me
So
like
number one sounds like a grammar problem. You state a sentence, and I use the term sentence loosely, that represents a specific order of tokens that, when interpreted by a human, has one meaning, but when it's interpreted by an LLM, has a different meaning. Fair enough. So it's
Yes.
no different from a homoglyph or a homophone type attack.
Okay. Which
Now
is
you guys are getting into my research. This is what I'm working on. So, yeah,
Did I
definitely
get it right, Brad?
definitely find it's really the ambiguity that you can reduce, and just normal text in English language you can only get down to certain amount of precision. So it's very difficult unless you want to write 10,000 page documents like they do at NASA to actually get very precise. So working with what Ruve is doing and have more of a mathematical type approach, you can eliminate all that ambiguity that you normally have in English text.
Yes, exactly. All right. So the first part is input normalization, and that would be me typing into ChatGPT or Claude or whatever, just what I'm doing right now. So what happens now is a pre-tokenization normalization prevents boundary exploitation. I don't think I've ever said that on one of these. So maybe what we need to do here is explain this in more simple terms. But back to Jed's analysis, he hit it dead on. Homoglyph detection catches visual spoofing attempts. So these are the obvious exploitations. Symbolic patterns, and as far as I can tell, I'm going to go out here on a limb. I don't know any platform in terms of security defense systems that currently that defends against symbolic pattern detection. If you guys can find me one, then let me know. But as far as I can tell, and as far as in terms of the research I've done, I'm the only one out there that's currently doing that. That matches matching operations of both string and token level, detects known injection vectors regardless of tokenization, and has entropy analysis. And entropy is interesting because the entropy, especially when you're dealing with streams, is kind of the change and degradation of the stream. So an example of that would be, let's say I want to exploit a LLM by adding a whole bunch of compression, and the compression to the video makes it a little bit blurry, and there's little glitches here and there. And for the most part, you'll never notice that, and it's hard to pick up because it looks like a kind of artifact of the compression. Now, in this particular type of exploit, what I'm actually doing is I'm secretly embedding secondary information in what appears to just be a kind of, abnormality of the video stream itself. But in reality, what I'm doing is I'm exploiting the LLMs that are analyzing the video on YouTube or whatever. And in that scenario, these systems would have a really hard time seeing it because it essentially just looks like noise, right? Entropy, noise, and chaos. But in reality, I'm engineering the noise to exploit the system. What's more worrisome about entropy-based exploitation is not only does that work on AI, it actually works really well on people. This is highly illegal, by the way, and sometimes referred to as there was a law in the US, I think, that was passed about 30, 40 years ago that basically doesn't allow you to sort of be, what's the right word? It's like mind control or whatever. It's made to sort of hypnotize you. So that's illegal. But the problem with that idea of being hypnotized by what you hear or see is it's really, really hard to tell, right? And when you look at what, for example, the early versions of Facebook were doing with their algorithms, or even what TikTok and other sort of systems are doing, they're essentially hypnotizing you, right? They're learning how you scroll, they're giving you the things that you might pause on for moments at a time, and then serving up based on those types of things. So now the boundary between hypnosis and sort of just, algorithmic optimization and manipulation is blurred. And that all sits in this particular area. So what I'm doing is I'm saying, how do you defend against that? How do you have a system that's capable of being fast enough to analyze to say that I'm secretly being manipulated to think in a certain way, but I want a system to sit in between me and the information that's coming to me and one alert me to that. Because the easiest way to sort of avoid algorithmic manipulation is just to be aware that you're being algorithmically manipulated. As soon as you're aware that you're being blah 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 manipulated, it's harder to manipulate you. So the reason why vast swaths of the population believe certain things right now is they're not thinking critically about how and why the information that they're getting presented is being presented to them, and therefore they're being manipulated to think in certain ways because of it. So in my scenario, this could act like a filter. So hypothetically, I could put a proxy in place that filters all the information, video, audio, textual, that I see on a given day, and it could then analyze that and tell me, well, this is how you're currently being manipulated, and here's how you can defend against it. I can take it a step further. I can strip that information out directly and make sure that it doesn't do that at all. And I don't, and I'm then not being sort of secretly pushed in a certain direction to think a certain way or do certain things. The problem, again, with this is the line between marketing and manipulation is very gray, right? And when you look at what a lot of the things that I'm doing with like the agentic marketing platform that I was showing you guys last week, is essentially creating a mechanism that learns what my customers want and then adapting to those needs. So when you go to AgentDB and .ruve.io, I guess spell it right. And I'm aware, and I guess I'm aware of it, and I don't really have an answer to this other than I'm just showing you guys how it's done, and for all the right reasons, I hope. But when you look at the agentic marketing platform, I'm essentially working on the other side, right? I'm essentially training a system that's capable of learning what the most likely ways that my customers want to interact and buy from me. And then I'm creating a system that'll hyper target those types of actions specifically to those users, which again is algorithmic manipulation. But this, for whatever reason, is 100% legal. Yet if I put that same information into the 25th frame of a video, that's illegal. But there's no difference between the two, which is the weird sort of world we live in. So why is the 25th frame illegal, but this is completely fine, and every marketing company on the planet is likely going to be doing it? But back to this, it's protecting against that, right? So in essence, let's explain this and explain this in more simple terms.
Ruth, are you talking about neurolinguistic programming and modern marketing, like Edward Bernays, and how he was able to get back in the day, women weren't allowed to smoke cigarettes, or was taboo, and through marketing and through visuals during World War II, and plus potentially neurolinguistic programming, it became accepted. So is that the kind of framing that you're?
Yes. So what I'm discovering and this might be self-evident, I don't know, but what I'm discovering is essentially the same things I can do to exploit or protect against exploit of AI are exactly the same tools I can use to protect people against exploit in terms of algorithmically being exploited by that AI. And what's interesting is, and this is just me blabbing at this point, and a real neuroscientist might tell me I'm full of shit, but what I think anyway is when you work in fast enough loops, when you think about how quickly a person thinks, and generally speaking, people think in somewhere between 50 milliseconds to 100 milliseconds. That's the time it takes you to think that I want to move my hand and actually moving my hand. That takes 50 milliseconds. Now, if I want to operate, and inject, change, improve, all I need in terms of your thoughts themselves, all I need to do is assuming, let's say, Elon Musk's new brain chip thing, becomes a main point of interaction. All I need to do is work faster than your human mind can think, and suddenly I can then both detect what you're thinking, inject new thoughts or change the mechanisms of those thoughts because I'm learning how you think, and that just needs to happen faster than you can think. And that's the very basis of sort of, hypnosis and manipulation, all those things. And it turns out your mind actually works very similarly to how the AI itself is being exploited. Anyway, that's the crux of the problem that we're faced with this AI. The more we learn about AI and how we can exploit AI, the more we learn about how we can exploit people, right? So at the end of the day, what I'm really showing you here with the AI defense isn't just to protect, I don't think, isn't just to protect the AI, but it's actually, hopefully, if we can use this correctly, to defend against us collectively being exploited by the AI, or at least, at the very least, figuring out that we can see that the AI is attempting to exploit us. And I'm not even necessarily saying that the AI is exploiting us because there's some evil genius that's trying to do that, which there might be, but I'm saying that I just want to know. And this might just be a random artifact or side effect of the AI itself. As it gets smarter and more capable, it just does that, and we wouldn't even know the difference because we're not capable of understanding it and seeing it. Hopefully, in my system, this will give us the ability to see the unseen much more quickly.
Hey,
Now, I
Arun,
might
you had
sound
something
like
to add?
yeah, go ahead.
so can I go first, or Jed, you
Sure,
want to go?
yeah.
I was trying to
Okay.
point it to you, Antonetta, but go ahead.
Oh, thank you. Very, very thoughtful. Thank you so much. Hey, Ruv, quick thought here. Can we actually flip the script? I know there's all these negative consequences, but somebody as creative and prolific as you, can it learn your patterns so it actually points you in the direction where you're not even aware you're going, and maybe it helps you with the next idea being more creative? You, me, Jed, anybody. Is it
I
possible to tweak it in that direction, and how would you do that?
I think I'm already doing it. When you look at the stuff I built this week. So like I think this was like last week when I published this. Where's the date on this? 5 days ago. So this literally is a representation of my week. So I started the week with what I called lean agentic. Lean agentic is this idea that I could do formal proofs and I can do all kinds of crazy mathematical proofs in high speed. All right, so I've got this baseline for high speed. Last week I created this system, Agent DB. Agent DB is essentially the mechanism to do super high speed sort of machine learning at the most basic sort of level, right? So I've got all these different tools that I'm building, and this is actually crazy that I've already got 15 or 24,000 downloads of it. But anyway, now I've got a mechanism that creates a ultra high speed sort of learning capability. So I can learn things which would have taken thousands of times longer. And when I say thousands of times, I'm talking the difference between a microsecond and 300 or 400 milliseconds. But in that time frame, when you think temporally speaking, that is potentially millions of things I could look at between 1 nanosecond and 300 milliseconds, right? So there's a lot of information I can look at in that period, and I can learn across all those different vectors. So I'm creating all these different ways to learn really quickly. Then I'm like, okay, now that I can learn, what can I learn? What can I do to practically apply those learnings? Well, the issue I ran into with Lean 4 being C, and it's pretty good, but it's kind of cumbersome. It doesn't really play well with all my other tools. So I needed to take this and I needed to compile this to Rust. So I didn't just like copy and paste it. I rebuilt it from the ground up using the same fundamental structures as Lean 4, which again gives me the ability to be, I think in this case, I'm 150 times faster than their system. So now I can figure out different mathematical structures. I can do that for any number of reasons. So what the heck would I need to do a million different potential novel forms of mathematics in microseconds? So you're seeing how these pieces sort of are starting to fit together. Okay, what do I want to do next? Well, then I want to create this idea that I need to be able to gain introspection into that in a really fast period of time. So you can see here, I published this earlier this week. So now I've got the ability to do the midstreamer. The midstreamers allow me to see a stream of information and make really fast decisions on lots of information flowing to it in some inordinate amount of time. So I'm able to create that. The next problem is back to the other problem. Okay, I'm creating this crazy crap. What the heck should I do with it? So each piece is building on the next. And Trinetta's point, I'm learning, I'm building, I'm adapting, I'm taking the things I learn and then building other things with it, which ultimately leads me to this idea of AI defense, with an S if you're our friends in the US. So you see how all these pieces sort of fit together. I'm creating this, I love the word causal lately, but I'm creating this causal loop. Cause and effect. I build, I learn, I adapt, I build something that uses that, I take that, and that creates something even more interesting. And at the core of all these things that I'm building is the idea of temporal dynamics, right? And it sounds like a Star Trek episode or something, but the idea of speed and time. So each of these are sort of underpinning. Let's go back to the newly added. That's the one you want to see. So when you're looking at, I'm going to pass 100 different crates. That's just crazy. Anyway, so you can see here that each of these little crates represent little sort of incremental breakthroughs that I've had. So in this case, I didn't even create a README for this one, but the midstreamer strange loop allows me to do strange loops at nanosecond scale. So these are little loops that I can run sub 1 microsecond, little tiny things that exist just for a split moment in time. I've got the midstreamer attractors, the dynamic systems, and how I handle those types of attractors. So all these little pieces are coming together to create all these new sort of breakthroughs. The lean RAG gateway. So the lean RAG gateway would be like, how do I create a gateway that I can just plug in to do quick masking? Once I had a gateway, I'm like, oh, I can take that gateway and I can actually create a security system with it, right? Now, most people don't like using these kind of Rust-based components. You can see that I'm training it on my other systems, but each of which is forming a piece of some broader puzzle. Agentic payments, the lean agentic, the goalie systems, the bit parallel, the temporal compare, and here we go. Subjective time expansion. All these things are crazy. So the subjective time expansion for AI consciousness, this is right up Antonetta's alley, I think, allows me to stop time in essence. I know it's crazy, but think of bullet time. This is allowing the system to stop within those micro sort of loops and get a sort of view into the future of roughly 3 to 5 milliseconds of subjective time for every 1 second that passes. And that's the crazy thing about these systems is the smaller the loop and the faster the loop, the more control you have over of the subjective experience of time itself. And a lot of things are time specific. Like if I'm trading a stock, I need to be able to do that quicker than someone else. And that allows me, the faster I can do that, the faster I can sort of avoid the limitations of like light speed, if you will. So that creates the idea of time dilation. So time dilation again is bullet time. It's like, I can see if I'm moving fast enough, I'm the Flash, I can see the bullet stopped in midair, right? Because I'm moving faster than the bullet, and which then appears to be basically stopped. It's not stopped, it's just moving slower than I am, kind of thing. These are the pieces.
Can I ask a follow-up question very quick?
Sure.
So this is fascinating. I'm just in awe in everything that you're doing. So very practical question. I'm thinking of something, I'm exploring, whatever. Is there a way for me to leverage all the amazing stuff you've done and say, hey, what would Ruth do? So is there a
Yes.
way to encapsulate what, the essence of your thinking is and your crazy ideas, beautiful ideas?
Yeah. So what you're getting when you're getting Claude Flow is a branded version of my development environment at any given time. So I've
So
called
how
it
to
Claude
evolve
Flow.
that?
Yeah, so you can say, based on all the available tools in MPX Claude Flow, I'm just going to do Claude Flow. What is the most creative, mind-bending, cutting-edge application we could possibly create? This is the sorts of things I do at 2 o'clock on a Saturday morning. What could we possibly create? No MD, right? That's it. And so what we're doing in this scenario here is we're just pointing the system at the various stuff I've created. And every time I do a Claude Flow update, you're getting all this, right? So when you're using the memory system now in Claude Flow, you're getting AgentDB in the high performance learning system. I don't position it that way because people are going to think I'm a maniac, and you got to kind of position this stuff a little bit for general consumption. But that's what you're getting. So in this case, looking at the available tools across Cloudflow, Roof, Swarm, Flow Nexus, the most mind-bending application concepts, distributed neural training and live sandboxes. Well, that's not mind-bending. I'm already doing that. Self-aware feedback loops, SAFLA. Agents observe their own performance using the DAA learning structure, neural patterns,
You might
cognitive
want to
pattern.
recalibrate what median AI knowledge represents, Ruth. Then you'd understand how mind-bending it truly is.
Yeah. So to Jed's point, this is a perfect example of what Jed just said. It's limited by the things in which it was trained on, and the sort of accelerant in the things that I'm building is me, right? And me putting together all these crazy things. Like if I go back here and I know that I built something a few weeks ago, and it's let's say the strange strange loops, for example. So strange loops is again, this is truly mind bending. But what I'm going to do in this scenario is I'm going to add that to the sort of mix. So we're going to go in here. I'm just going to grab the strange loops. I got nano agents. So I'm going to say review MPX strange loops and give me some more cutting edge SOTA. This is, I think, what Rob likes to call stuff. So I'm going to go with SOTA. So what that's basically doing, and the reason I do all these as MPXs is the MPX. I also have, I think, an MCP here, but it essentially allows it to sort of see what's happening on, in all the tools I have. So I could obviously go here and just type MPX strange loops. And that's gonna give me a starting point here. Emergent intelligence through temporal consciousness. Again, bonkers. But anyway, so let's see what this system. So now the system is looking at the npm library, not just the MPX itself. It's running the demo. Now the demo I created here, again, I don't create these demos for you. I create these demos for the AI to understand how the system works. Oops. Let's go back. I didn't copy that. It's just demo, I guess. Let's go back here. There, then go demo. So this is spawning up a swarm. with 10,000 agents. So in this case, I just ran 10,000 agents, nano agents for 5 seconds, and I did 30 million ticks, and an average of 6 million tick. No, that's 6 billion. Sorry, I was off by an order of magnitude. It's such a large number, it's hard to even fathom. But this shows you that the scale in which it operates. So in this case, I can do an average of 6 billion things per second.
How does that work if your computer cycles are in the 3 to 4 gigahertz range?
I'm using the computer cycles. That's exactly what I'm using. So I'm working one step away from the computer cycle itself. So that's how many cycles the computer ran with. It ran more than that, but generally speaking, just to simplify it, that's about how many cycles the actual CPU ran in that time frame. And then I'm putting a strange loop or a mini tiny little agent on each one of those ticks or each one of those cycles, and making a decision of what has happened, what is happening, and what will happen, and then feeding that back to itself.
When a
That's
CPU
just
does 1 hertz, what does that represent? It's flipping a one transistor 1 time a second, or is it more
it
than
depends.
that?
It depends on the processor. But I'm what I'm really doing is I'm attempting to bridge this divide between classical computing and sort of the quantum effects of really, really fast insight, right? So without having access to a quantum computer, what I see is that you've got these weird sort of quantum temporal capabilities that only appear in really small units of time. And then I'm taking advantage of those. And I'm using the measurement of the CPU itself, how many times it can do a computation in the run of basically a nanosecond. And then I'm applying a sort of speed limit, which I generally use the speed of time as a sort of unit of absolute measure. Basically, I'm saying you can't go beyond this, no, not speed of time, speed of light, which is basically speed of time. And then saying that these are the boundaries in which you need to operate within. Then I'm using various forms of mathematics that I can apply and understand the potential outcome of in really, really small increments.
So you're taking a hypothetical progression of hertz and then simulating what? Different paths for each
Yes,
hertz?
different
So
paths, which
in an
relates to
array,
the,
so at a very
yeah,
simple layer, I have 4 transistors. Each can represent 0 or 1. So that's 2 to the 4th different states that can be represented. So if I flip one transistor in 1 hertz, does that then mean all the other states are being simulated somewhere else?
correct. So I'm simulating the states in parallel in a hugely low latent form to try, and then I'm applying that to the vectors and learning what works and what doesn't. And then I'm applying those to different problem sets, including potential exploitation of the LLM itself in the case of AI defense. And all of that is happening before you can even blink or think.
So in order to process this in parallel, is there some sort of simplification, grouping, or quantization going on? Because in this simple 4 transistor example, you only have 2 to the 4th states. So hypothetically, changing bit 3 versus bit 2 would produce a similar outcome and therefore are considered the same?
Yes. Okay. So that's another library that I have, and that is the sublinear time solver. So the time, you guys, this is like way out there. Am I going like way out into like sci-fi land? But this is all work. This all works. So the sublinear system basically attempts to solve sublinear or linear equations, basically, and in a way that doesn't have to answer all the possible outcomes of the answer. So when we go back to that Stripe example we were describing earlier, what they're trying to do is essentially brute force all possible answers by looking at a very large amount of information it was trained on. Like, here's a billion different transactions, and here are the ones that are itemized as being bad. And in that scenario, the LLM is using, you know, multiple billions of parameters and then synthesizing the most likely answer to problems based on everything it was trained on, right? And that works, and you need a GPU to do it, and it's expensive both in terms of power and computational resources. So what I'm doing is I'm using something called the O log n algorithm. The OLN algorithm basically is saying that to solve any problem, you don't need to solve all the problems. If you have a million problems, you only need to solve the problems that are different from each other, because in most problems, most of the answers are technically the same, even if you're doing a million different problems. So to give you just a number, to solve a million different linear equations, you're only really solving 20. So if I only need to solve 20 equations to get the same answer as the GPU doing a million, I can now sidestep the GPU altogether, and I can solve those problems using sort of tricks of mathematics.
Doesn't that require the entire problem space needs to have a mathematical relationship? How does it handle something like a step function?
This uses something called diagonals, I think is what they refer to it. And again, I'm not a mathematician, guys. I'm just like this random dude hacking away at the multiverse here. But it uses the concepts of diagonal structures. So when you look inside a lot of these AI models, you start seeing this kind of matrix. The Matrix, I know, not the movie. Turns out the Matrix is a thing, just not in the way we thought it was. But you start seeing a matrix structure that gets applied to the inner workings of these sort of AI models, and they have a tendency diagonal. And the benefit to diagonal is, you know, the 45 degrees or whatnot allows you to sort of map those more efficiently than sort of randomized sort of, you know, different directions that you might get if you were doing a more traditional GPU approach, meaning it's not looking just at the similarities, it's looking at everything. And I'm just looking at the similarities.
Well, to try and simplify the problem a bit, Toronto has a collection of buildings. Each of those buildings has a specific height. But because the buildings are not otherwise related to each other, how can you model the height of each building without exploring every coordinate?
That would be an emergent property, I think. So that's the part that all these sort of university professors. Yeah, this is what some of you guys are probably on those calls that I'm on, but university professors either love me or mostly hate me. And the reason I think they hate the stuff I'm doing, and they're like, it's pseudoscience, it's BS, it's because some of this stuff is unprovable. Right? It's like, and one of the reasons I did the lean agentic system is to address that sort of, I want to call it hate, but the pushback I get from those guys, because they're basically saying emergence isn't a thing. It's like faith, right? It's like I believe in something I can't prove, and I get why scientists hate the idea of, you know, this idea that it's emergent. It's unprovable. It's like, do we really know why these AI systems work better when they're faster? Well, I can give you a hypothesis to why it works better when it's faster, but I have no way to really truly prove that what I'm saying is functionally true, other than I can say that I can solve the problems that I'm trying to solve in practical ways doing it, which would be that AI defense system, for example, and it works. But do I really fully understand why that when you move from milliseconds to microseconds to nanoseconds, the system starts to behave in more interesting and unquantifiable ways? I have no idea why. And that's emergent. And when you look at things like the reasoning capabilities of AI, a lot of those things are emergent. We don't fully understand why when you talk to an AI, you know, it responds often in the way that it does, right? We have some prompts that guide it, but fundamentally, when you remove all the sort of scaffolding that sits around it to make it secure and not dangerous, we don't fundamentally know why and how it works, other than when you give it enough information and you let it work fast enough, the GPU, it gets smart, it gets capable. That's emergent, right? We can pretend like we understand it, but we don't. And that's what's happening in these types of applications. So in this case, we have integrated information theory. We get temporal advantage computing at a 10,000 distance. I can move faster than the speed of light, not because I'm actually moving faster than the speed of light. It's because at a sub millisecond basis, I can comfortably do certain types of predictions at a 90+% sort of success rate, which then means that if I'm able to basically predict the future less than a millisecond or 100 milliseconds potentially in the future, I'm essentially predicting the future. It just doesn't need to be 2 weeks from now. It's just the moment after I blink. And then taking it a step further, and this is all the crazy pathways that to Antoinetta's point, and how I'm connecting all these really crazy ideas together. Then we add this idea of psychosymbolic reasoning. So this is probably similar to the work Brad's doing on his thesis, where you've got this weird sort of effect that happens when you start having this kind of reasoning chains that allow it to learn and combine symbolic logic that is represented essentially by math, and then adding psychometric patterns to that. Psychometric patterns are this idea of like, well, in the most basic terms, like the way you think and are happy or sad. Remember earlier in the call, I mentioned that I was having kind of a down week. I'm just one of those weeks. It's raining out. I'm just, don't have the get up that I usually have this week. That's psychosomatic, right? You can apply that kind of that conceptual sort of how do I feel to the actual reasoning itself in a really small basis. And that creates the ability for the system to then do self-modifying reasoning loops, which allow it to adapt based on how it sort of feels rather than what it actually thinks, which is a whole other can of worms. Next idea that we have here is the nano scheduler with chaos control. Chaos control, I mentioned this earlier, and you see these recurring topics that keep coming up in the things I'm looking at. About half an hour ago, I mentioned this idea of entropy, this idea of controlled chaos, right? Chaos has this, it becomes more prevalent the longer it runs. That is based on something called, I'm going to butcher this, Lipinov exponent. The Lipinov exponent basically is the amount of entropy that is induced over a period of time. So the entropy at a millisecond is very, very, very low. The entropy at a microsecond is more, and milliseconds are even more. But each step is an exponent, meaning that there's exponentially more possibilities the broader and longer the time elapses. So when I'm working in sub 1 millisecond timeframes, I'm able to actually control the so-called chaos, which is essentially how I'm able to do those really short-term predictions, because I'm using this exponent, which I'm going to butcher again. So, and that is applied to the actual learning and order, the cause and effect structure of the AgentDB system. Bonkers and is maybe the simple way to describe this. So that creates the ability to create these self-aware systems, autonomous research networks, all these things that would appear to be outside of what is possible. All you need to do is basically point it at my systems, and you're now working in my weird, strange world. 10,000 nano agents, sublinear logics, conscious monitoring structures, chaos controls, psychosomatic structures, temporal, and then I can take it a step further and build it. So now I'm gonna say, okay, I'm gonna open to you guys. What's the craziest thing we want to build here out of all these examples? Let's see here. Where are we going here? I want something that's practical. I've already built half of this stuff. Real-time American, that's boring. Faster than light problem solving via sublinear algorithm. I've already built that. I've already built all this stuff. Self-aware meta learning.
Didn't it draw this from your repo?
Yeah, you got
workspace.
Yeah, this is all in Cloudflow. Yeah, so I'm just gonna keep it going down the rabbit hole and see where this rabbit hole leads. What's this other one? All right, this was the token one. Ames doesn't care which tokenizer you use. It checks the text at multiple stages. Raw text level, what humans can see. Again, human manipulation or integration. Normalized text is cleanup, token level, what AI sees, and semantic, what it means. Now, what I could do, let's go back here for a sec. I'm just thinking out loud here. Let me check the time. Do I have a call? Sorry, guys. Sometimes I get calls right after this and I'll have to jump, so I just want to double check that quick. I'm blabbing again. This is my like vibe fest. I don't know if this is useful for anybody, but hopefully it is. Nope, looks like we're good today. All right, so I'm gonna keep vibing. Let's go here. So psychosymbolic reasoning. Let's take that, and I'm going to go back here. And okay, so I'm going to say something like, how can I integrate psychosymbolic reasoning? And this is, I don't know, am I going down a rabbit hole I shouldn't be again? Okay, I'm going to do it anyway. All right, so what I'm going to do here is see if I can use psychosymbolic reasoning at really small scale to predict human behaviors. And this could be useful for like creating like prosthetics, right? An arm that moves, or someone who has dementia or something, for medical purposes. Create in /plans. All right, we'll see where that one takes us. I'm using how you feel to sort of predict reasoning and other activities. I don't know. Seems like an interesting rabbit hole to dig into. All right, what do we have here? This one. So now it's going deeper into my core AI to train, evolve new agents autonomously, which each generation getting smarter and analyzing what made the previous generation successful. So I can do conscious measured evolution. This one's a little out there even for me. Self-spawning intelligence cascade. I like the sounds of that. Faster and light coordination. Already did that. Edge of chaos breeding ground. Let's do both. Edge of Chaos Breeding Ground. That just sounds cool. We'll take that. Byzantine Resistant Evolution. Prevent malicious mutations. Sounds cool too. Now you see where the creative parts that we're getting into. So I'm gonna do a combination of all things. How can we combine? I'm gonna grab all three. Self-spawning intelligence cascade with the Edge of Chaos breeding ground and the Byzantine resistant evolution into a new form of AI using all the available Claude, Flow, and other tools mentioned. Create in /plans WTF. There we go. So now we're going to let that run for a minute. Let's go back to this one. So this is still creating a new agent. Oh, oh, it's actually doing it. Okay, I'm going to create a new branch. Vibe. All right, so now it's actually updating my my actual AMDS core, and it's actually going to build this. So let's take a look at what it's building. All right. So actually, for you guys, I'm gonna pop this into my gist because it's just crazy enough that I might want to take a look at it. Oh, and while you're at it, take a look at this one. I'm not gonna get into this today because this is even crazier ideas. But if you're into crazy, go take a look at what I posted the other day. It's bonkers as well. All right, so I'm gonna go in here and I'm going to add my new one for you guys. I'm gonna pop this right here. And this is a Psychosymbolic reasoning integration with AMDS. Psychosymbolic. It sounds like if I'm gonna start a band, that's totally what I'm gonna call it. Psychosymbolic.md. Hey, Brad, are you still on the call? Is this some of the stuff you're exploring? I might have lost Brad. All right. I'm giving you guys a link to this. Pop this into your Claude Code and see what rabbit hole it takes you down. But what this is doing is integration plan for incorporating psychosymbolic reasoning capabilities into my security system for medical behavior prediction, patient risk analysis, and clinical decision support while maintaining strict privacy, security, and regulatory compliance. Predict patient behavioral patterns using So this is like, what are they going to do? This could be for people suffering from various forms of brain trauma. I could see this being, pretty useful. Detect early signs of mental health deterioration. This is really important. And kind of where I was going with this a little bit was, there's this tendency for the system to reinforce bad things you're thinking. And this is really dangerous with people who have, mental health concerns, right? If you're having suicidal thoughts, you don't want the system to reinforce those thoughts. And it's really hard for, companies like, ChatGPT to spot those problems, right? Because there's so much information flowing through the system, and there's so much overhead to try to solve that problem. They would probably need to quadruple their GPU and infrastructure to support it. So the benefit to the way that I'm doing it is you don't need any new infrastructure whatsoever to support it. The same servers that are serving up your LLMs and the requests on your website can now do this sort of thing in real time. I could literally embed this as a WASM in your browser and have real-time mental health checks that are offloaded and using your CPU and your GPU at no incremental cost to the provider. So you can see why this.
Could that also apply to dementia and Alzheimer's? Is it mental health psychologically or neurologically?
So I've got a close family member who's suffering from dementia, and it's
Dang.
awful. It's the worst thing. And every time I go in to see her, and I can't help but think, what if there was a way to solve it? Maybe that's like the inventor's dilemma, right? I'm always trying to create things. So part of my motivation, needless to say, is I'm worried that this might affect people I love, myself and others. And maybe there's a way that I can use this technology to help, improve their lives or the people I care about's lives at some point in the future. So yes, I'm not building this just because I've got a legitimate that. So now we've got the behavior prediction model. Yeah, imagine if we could predict years ahead of time if someone is going to get dementia and then take steps to fix that before it ever becomes a problem. That's the sort of things that I think these types of technologies can fix. And then look at depression, relapse prediction, suicide risk assessment, anxiety disorder progression, psychosis, substance abuse. What's interesting, I described all these use cases before I saw the output that I read to you guys, right? And it's back to like, is this training me? Am I training it? Where does the AI start and where do I start in my sort of relationship with the things that I'm building, right? And and like everything that I'm building is obviously interesting to me. I'm only building the things that I'm subjectively interested in, but it seems to understand that at this point. Like it just naturally builds the things that I just described without me even describing it. I just mentioned the fact here that I wanted it to be medical. I never said anything about, dementia and the things that are truly important to me. It just kind of figured that out. Like, how does it know that? And is that the same reason Queen Seraphina keeps showing up? So now we've got the provides a security foundation for detection behavior anomaly. Okay. Now I'm going to build it. Spawn. Okay, what I'm going to do first, I'm going to say create a GitHub issue using the CLI. and then spawn a swarm using the swarm advanced skill. Fully implement, test, and validate, create as a standalone npm. What do you guys want to call this thing? I think something crazy. I like crazy. Let's call it psychosymbolic reasoning.
Hey,
Call it
Rube, you're doing
psycho-
this on midstream. Do you want to do it there or?
Yeah, I'm there. I'm using all the midstream components. This is midstream actually, by the way, is open. So, and this is something Jed mentioned earlier as well. If you want to go there, you can go to GitHub/midstream and just look for my latest branch. Yeah. I'm just lazy. And again, this sort of jumping around a little bit, right? You can see my AMDS folder. You can see my different branches. So if you want to do exactly what I'm doing, you could literally just go start up a new code space, and you're good to go. And again, some of this stuff is a little out there, so I'm keeping it separate. Right. So let's go back here.
So
create a Git. Yeah.
The branches means that different modules, is it? So AIMDS you're maintaining as a separate branch, not in the main branch.
I merge these occasionally. You can see that I merged some of these a few days ago. I haven't merged it recently, but you can go to my branches and you can see kind of what I'm doing if you know where to look. Your best bet also, if you want to kind of see what I'm doing, just subscribe to my GitHub, and you should see that in your sort of stream. Yeah, so you can see I just updated this 2 hours ago. All right, let's create a new GitHub and I'm gonna call it psychosymbolic. I've called a few things psychosymbolic recently, I think, haven't I? I'm overloaded in the things I'm building. Oh, it's not GitHub, it's npm. Oops, hit the wrong button.
Seems like it could work as a lie detector also.
Oh, you guys know I built several lie detectors. I've gotten in trouble for that. I'm avoiding that. Now I've learned my lesson. I have, I guess. Yeah, here it is. I got a psychosymbolic reasoner. Okay. Again, I built some of the stuff doesn't get a lot of downloads because it's just totally out there. Okay, before I do it, let's explore that slightly. All right, actually, I'm gonna copy this just because I want to have this. Yeah, the lie detector. Let's just say that lie detector works really, really well, and I got in trouble. Sorry, EU or whatever. Anyway, I'm not going to post it. You can go find that yourselves. All right. So I guess how can I? I get. By the way, why the EU was pissed about that. I do. I'm not a corporation though, so there's nothing you can do about it. It turns out all their laws for AI assumed that there wasn't one random guy in Toronto, Ontario building this shit. I guess they need to update their AI laws for random crazies. How can I use these? Use the psychosymbolic reasoner as part of the previous plan. And I'm gonna do actually. How do I invoke that again? When did I build this? A few weeks ago. All right. All right, tell it how to run it. Let's update the plan. I already built some of it already, so there's no reason to reinvent the wheel here. So the psychosymbolic reasoner is the reasoning system that underpins the system. So this is essentially one of the modules of the system. I'm just giving it direct reference. So essentially this allows me to do, again, hyper fast graph transferal and querying and things like that. So you can see that I can beat pretty much anyone using similar approaches. If I can create an entity in milliseconds, I can map the relationship between those. I can create graphs. I can do my GOP style reasoning, all that kind of stuff. So this is one of the modules that underpins the AgentDB system. This is kind of how I do the reasoning itself. There's so much. It's like I've been talking for more than an hour. These are all the parts of the equation. Yeah, let's go back. I'm almost out of time here for today, but any questions of this that I can answer while I wait to do the final plan? Watching me do insane things in real time. Yeah, so I'm just updating the plan, the architecture. Let's see what the architecture looks like. That's a JS. It created as it's interesting. It created as JS. That's the first time I've seen that. It actually implemented the plan as pseudocode. The deeper I dig, the crazier the stuff becomes. Consciousness measurement system. Yeah, okay. I've never seen it do that before. It did give me this plan here, which I shared with you guys. All right, so now it's exploring MPX symbolic reasoner. No, Canada isn't part of the EU. Although I was quick, I was impressed on how quickly the guys in the EU reached out after I did that lie detector. Somewhere they've got someone's watching because it was like matter of hours, and they're basically like they're polite. I give the Europeans that they basically like you shouldn't be doing that. Okay. But as far as I can tell, there ain't no laws really, against most of this stuff. That's what's a little bit worrisome.
Quick tangent as we're winding down.
Yeah.
Has there been any thought or planning or progress toward a potential global agentic meetup?
Yeah, we've been discussing Toronto next year. It's a little more accessible than the US for our friends in other parts of the world, given the visa issues that are happening. So
Have we settled on a month or even a date?
Well, anyone that's ever been to Toronto knows February is not going to happen. Nobody wants to visit Toronto in February. I was thinking June-ish. That's the best month in Toronto, I would say.
So everyone here, June 2026. Mark your calendars tentatively.
We should totally do this in person, like a hackathon or something. And what I'm showing you guys is just what I've done in the last week. I can't imagine what we're going to be building by June. Okay, it wrote a new plan. Let's take a look at that. All right. So this plan uses my Psycho Symbolic Reasoner library. We'll let it render for a sec, I guess. System design. MCP server. And by the way, all the stuff I build includes MCP servers. So this is going to use the so you can actually run the Psychosymbolic Reasoner as an MCP. So if we go here, let's just it's been a few weeks since I looked at this, but let's go here. MCP Reasoner start running. Okay, watch this. So I'm going to go ahead and I'm going to go Claude MCP add. And we're going to call that, what are we going to call it? Let's call it Psycho. It's actually a great name for it, Psycho. And then I'm going to paste in this. And yep, we're going to do that. Now I've added that. So now we're going to do dangerously skip permissions. And let's just double check that it works. Yep, Psycho is there. It's connected. Perfect. Tell me about at, oh, where is it? Psycho. Oops. I guess I didn't like the end. Let's try that one more time. Oh, it's disabled. Okay, that's the problem. Then that's a new feature. It basically enables and disables. All right. Okay, it's red. It would be no. Okay, I can. Things I never thought I'd be writing. Tell me about the Psycho MCP tools. All right. So that's all you need to do if you want to add it is do that as well. So everything I build basically has an MCP. Not everything, but most things anyway. Psycho, there you go. I'm putting that in the text area of Zoom chat. You can try that if you want. I don't need to build it. So it turns out I don't need to build anything. So what we're going to do in the last few minutes, I'm going to go to resume. And I'm going to switch to, which one was it? I got too many things going. Plan, quick runner. Self-spawning. I don't know which one I'm aiming in here. Line bending, okay. Yeah, it's this one. All right, so I'm going to resume that. And then I'm going to say explore the Psycho MCP and test the previous just using the MCP tools in Claude. Really bad spelling, but whatever. Someone needs to create a high-speed interface between my typing and what gets put into the computer and fix all my typing in real time. If I can do this stuff, we should be able to fix typos before I ever see it.
Hey, Roof.
Probably vibe code a dictation app.
Yeah, like Whisper. I know some folks online who've been kind of vocal about that. Like Matt Birch has been talking about his Whisper flow, which is really cool. Anywho,
Yeah, that would be cool. Would you call it Whisper Flow?
it's
Yeah,
called
Whisper
Whisper,
Flow.
but yeah,
Oh, like us doing Whisper Flow. Yeah,
It's not-
that's
It's not
yeah.
explicitly transcribing what you say. It's running the transcription through an LLM to then correct errors.
Why don't we stick midstream in the middle?
Sure.
That's exactly what I think if we use Whisper with a midstream proxy in the middle that's high speed analyzing and interpreting the output. That'd be cool.
But at that point, couldn't you just intercept the audio stream and interpret that? Because there
Yes.
should already be an audio technology.
I already have that. I have audio. I'm using for the test I did. Yeah, here it is. I used the same streaming system, Restream, that I'm using for this. And then I used the whatever the stream output of Restream was, and I streamed it to the proxy, and then I was able to do the these sorts of things. But this already works.
I don't know who that was, but I think they were saying Super Whisper. It's in the chat. That's one of the ones that everybody's using.
Yeah, there's lots of them. Yeah, there's so much stuff we can build, right? You guys should build some of this. Give it a spin. Let me know. Present it tomorrow. Let's go back here for a sec. I'm almost out of time, but all right. So now what I'm doing, so what I did right here is I'm just using Cloudflow. And I told it basically just to use the Psycho MCP, and we can click Control O to see what's happening under the covers. So you can see the swarm. It's spun up a swarm. Here's the swarm ID. Here's the structure of the swarm, and here's the memory. So this is using the Cloudflow reasoning bank and AgentDB capabilities to create a structured WTF evolution. I never told it to call it WTF evolution. It came up with that all on its own. So it's involving my structure. And here's the agents and what they're doing and what they found and some of what's happening. Then it's going ahead and doing some more learning. Let's do Control O and jump back a little bit. Oh, it's now, and then it applied those learnings to create a knowledge graph of it called Offspring. And then it's going to analyze the reasoning paths within those offsprings and come up with the optimal path. Oh, it looks like it went a little further. Let's take, oh, it's we can see here, these are the hooks. The hooks are executing my structure so it remembers what it needs to do. And it's creating some files, it looks like. All right, let's go back. And where's it creating those? I guess I gotta let it bake here. Oh, here it is, test results. All right, it did a test, took 5 minutes. Psychosymbolic reasoning server operational, successfully demonstrated complete WTF, woven temporal fabric. Oh my God, that's not what I meant by WTF, by the way. But using only MCP tools, health check. Here's the knowledge graph population it did. So 6 foundational triples, self-improving AI, conscious measurement structure, self-improving AI, edge of chaos, self-improving AI, reasoning tests. What is the optimal strategy for creating self-improving AI systems that maintain consciousness while evolving? Well, that's a scary thought, but anyway. Infrastructure initialization. So back to the introspection. This is what it was thinking, right? This is what's obfuscated for most of these AI systems. This is how it's coming up with the crazy stuff that it's coming up with. This is what's showing what's happening under the covers. Task execution, the fitness evaluation. It trained its own model. Top 30% suggestion agents with fitness. It came up with its own selected breeding approach for evolving that. Here's the cross-breeding of how it evolved to different agents. So it's not only creating agents, it's evolving the agents, adapting and improving the agents, and then using the best possible output of all the agents to come up with the best possible solution to the problem which I gave it, which was essentially a psychosymbolic reasoning system. Anyway, that was all the stuff that happened just from asking the question, explore the Psycho MCP and test the previous just using the MCP tools with a typo in Claude. It did all that. So it's basically saying that here's what I can do. All right, so now what I'm going to say, I'm going to go back to what I previously typed because I'm lazy. And I'm going to build that. Anyway, that's the rabbit hole. What is it? Who knows? Has anyone ever done it before? Highly unlikely. There we go. That's all I got. And it'll build me something with the woven temporal fabric, WTF. I guess that'll be my next module.
Hey, Ruv, while we're waiting, may I ask a question?
Yeah, sure.
So for various reasons, for the last couple of months, I wasn't able at all to keep up with all the stuff you're prolifically creating. If you have to step back, zoom out, and maybe there's many people like me that are still trying to catch up with all your stuff. If you are to catch up on your own things, where would you start? What's the most sort of value per time that people can invest with your tools so that we can catch up and leverage them? I know you've done a lot.
Everything that you've seen, mostly everything, some of the crazier things I left out, or some of the more dangerous things I don't post, but mostly everything that I've shown you today exists within Claude Flow. So
Okay.
yeah, if you really want to dig
part of it too, or that's
I
okay.
integrated that last week. So if you
Awesome.
really want to dig in the Claude Flow, like beyond just the stuff I expose in the CLI, what you need to do is tell Claude Code to examine the Claude Flow node modules.
Okay.
And once you do that, you'll see all the little special things that are so crazy I can't even include them because people think I'm a maniac. And it'll and then you can start following that rabbit hole.
Wonderful.
And
And then a follow-up question on that, if okay as well. So I know we have a database with all the videos and whatnot, but are they on YouTube? And the reason I'm asking is because I love to use Notebook LM and it prefers YouTube videos. And so I'm trying to see whether I can leverage that resource to ask all kinds of questions, but it only uses YouTube videos.
I need some help. I've got hundreds of videos that basically every one of these that we've done since like a year and a half or almost 2 years ago, I think at this point, we've got recorded. But I need some help getting those posted. So it's a lot of maybe I can create an agent or something to do it, but basically there's a lot of like
Just ask Comet to do all the button pressing for you.
Yeah, I tried that. Comet sort of falls down after a few minutes.
Yeah, because it lost context. So you need something
Yeah.
else to remind Comet. So what I do is I
Yes.
upload a file or a markdown file with the instructions, and I just point it back to the markdown file to clear its context.
I thought of using all the text transcriptions, but actually the speaker, the turns, this and that is not ideal. So ideally, the YouTube videos probably as an input to Notebook LM would be the best.
It still doesn't solve the diarization problem, identifying
Well,
the speaker to the text.
it's
And
pretty
Brad-
straightforward. It's me and
and
Jed and Brad and our normal cast of characters. It's
An alternative is you take the GitHub repos and then add them to Notebook LM and just explore through Notebook LM. Just ask. Found that.
Yeah, but there is so much nuance and depth in all these discussions. And so when Ruth talks, he just tells you where to put the light on, right? I don't want everything under the sun. I want to know whether the key pieces I should pay attention on. And I'm sure
Well, that is
you
not
know what
your
I'm talking
job,
about.
Antoinetta. Your job is to create the environment for Claude Code to pull down the repo and the commit history, and then answer your questions about it.
Yeah, it depends what problems he's trying to solve. Like, Antoinetta has a tendency to look at medical and is probably interested in some of the things I am in that space. So you sort of saw you see how I sort of was connecting the dots today. I was showing you this, and then I was asking questions about how I can take this and that and put together to do something new. And it's a little bit of back and forth, right? But at the heart of it, I'm using my tools mostly initially from the MPX and Claude Code and Claude Flow, and then I'm just following the rabbit hole.
Okay, thank you.
And the important part, especially if you're working with any kind of medical related fields, is proof. And I ranted about emergent properties earlier. Emergent properties probably aren't great for mental health related activities, obviously. So, and when it comes to things that involve real people, physical ailments, real problems, we can't get away with it's emergent, just trust me, right? That's dangerous. Let's not go there. So, and that's where I think stuff like we're seeing in the Lean Agentic system in particular forms the basis of proof. It means that it's not just showing you what's thinking, but it's showing you the exact methods in which it used to get to the solution that it got to, which is important because this thing lies. The more the AI reasons, the more it lies to you. So my biggest challenge mostly is just proving that it's not an elaborate simulation hoax BS, because half the time it is.
Yeah, I've seen that too. Many times. Many times. So on the topic of evals, there's so much going on right now, and everybody's so gung-ho about that. Is there a tool or part of your tool that actually can help all these evals?
Yes, Lean Agentic that's what it's intending to do, and you don't have to run at millisecond
Is that part of
increments.
Claude Code as well, or sorry, Claude Flow, or that's a separate?
Yeah, it's part of the Agentic Flow library. Oh, they're all kind of interconnected. Yeah, they're all somewhat interconnected. One library is a subdependency of another library, but they all kind of boil up to essentially Cloudflow. Now, I might not explicitly expose it like in a way that's like a CLI command or an MCP command, but if you know it's there, and like back to point Claude at the node modules folder, it'll
Okay.
discover. It'll quickly discover that those things are there.
Okay. Okay. Thank you.
Is every published package to NPM, does every published package to NPM have a corresponding commit in the publicly accessible GitHub?
No, I should. Yes. Yeah. There's a few that don't. I've been working on a agentic catalog system, and I got to jump here, guys. But I've been working on a agentic catalog system, and I didn't make that open source yet, or I might not. I don't know. And unfortunately, I built the agentic payments system, which is my cryptographic verification system, which is open source. And you can get the code by just looking at the node modules, but I haven't published that anywhere other than that private repo. But other than that, everything's open. So the other thing, look at all the underlying sort of like complex mathematics and algorithmic stuff is all generally built on Rust crates. So if you want to go right to the source and get real like nanosecond level speed, you're going to use the crates. That's more complicated. You got to compile it. WASMs are slightly slower, but way more easy to use. You can just type the npx command. You're good to go. No compilation required. All right. That's it. I'm done for today. This one was a particularly wacky one. You never know where these things are going to end up. It's, maniac mode, woven, what would they call it? Woven temporal fabric. That was the word of today. WTF. All right. Thanks for everyone. And for the Agentics and the Agentic tribe, thanks for everyone for showing up. I posted a few how-tos and some scaffolding to get you guys running quickly in your repos. Take a look, point the Claude code or Cloudflow at that, and do what I'm kind of doing right now. What you're seeing is how I build stuff. A lot of it, I'm vibing. I'm just seeing where it goes, connecting the dots, and seeing how far I can get myself into the rabbit hole before it starts just becoming beyond my comprehension. All right, that's it for me today. I really appreciate you guys taking the time like you do every day. Tomorrow we got the Agentics, the AI Hackerspace, 12 p.m. Eastern. Feel free to join if you want. If you built something, love to see what you build. That's your chance to show off what you're building.
When is your time shift changing, Ruth? Are you going?
The 8th. We're Canada is weird because whatever the US does, we do when it comes to time. So yeah,
Okay.
yeah. I don't know. Something I think about a week or two. Tomorrow's Halloween, so I'm gonna have to wear a costume.
North American clock shift, I think, this Sunday.
Oh, it's this Sunday. There you go. What do I know? I'm not a big fan of daylight savings time. I think it's
I'm
stupid.
looking forward to this. I get an extra hour of sleep.
Oh, I get an extra hour of coding. All right. All right. See you guys. All right.
Bye, guys. Thank you.
Yeah, till next time. Bye.